Hello once again, everybody. This is Mr. Wakefield looking at the back side of section 8.1, the back side of that worksheet. And we're going to look at now the third method that we have for solving quadratic equations. All right, the first one, of course, was in section 5.7, the factoring method. The second one was the square root property on the first half of this current worksheet, 8.1. And so now in completing the square, that, to be honest with you, is probably the toughest one for students. There's a lot of different components to it, and we got to make sure we get them all right. Okay, so let's be extra sure that we're ready to go here mentally and just paying attention to every little detail, okay? Got to let you know here as I look on the front side with the directions here and with some additional notes that I have. Again, just like with the square root property, it's very important that you have to have x squared here, not 3x squared or 4x squared, but x squared. All right. But the difference is that it's not by itself. Okay. You want to have x squared, and then you have the x term here. It could be minus also, but this is the x to the first term with its coefficient here. And then you've got the constant term, no variable on this side at all. All right. You want to get the equation to look like that. All right, and we're going to talk about how to do that. Usually there's one or two steps that you got to do. But it is extremely important, you guys, that you do not jump down to the second step where we do all this stuff up here that I talk about until you do that. If you go to the second step too soon, all right, and that's probably the biggest, most common mistake that students make. All right, you're going to end up losing a lot of points on that problem because it's near the beginning of the problem, and the problem just goes completely in the wrong direction after that. So it's hard for me, grading your exams, for example, to give you a whole lot of partial credit for that because it's at the beginning of the problem, and then it just all goes wrong after that. So please remember x squared, all right, and then the rest here. Let's see how we need to do that. So you can see here on this first problem here, we have x squared and we have the x term right next to it. That's already on one side. So we need to get that 8 and move it over to the other side. So the goal here, unlike the factoring method, is to get the x squared term and the x term on one side, where the x squared has to have a coefficient of 1, which it does. It's invisible, but we know that means it's 1. All right, and then you need to have a constant term on the other side. So the way to move terms around, like always, in a linear or quadratic equation, unless there's parentheses to clear out first, is to add or subtract them over. Okay. And so we get this right here. Okay. Now you can see that it looks like that, doesn't it? Okay, it looks like this right here. X squared, and then the x term minus 4x. Again, this could be minus, and then the negative 8 is a constant, no variable in the negative 8. All right. So that means that I'm now ready to go to step 2 because I did it. I did what they asked. So then I go to step 2, and it says to first of all figure out what this thing is equal to, and then you add it to the side that has the variables in it already. Okay, so first things first here. It says here b over 2 squared. What is the b in this problem? And then we'll figure it out. The b in this problem, and again, you can't figure out what b is until you have done step 1 first, because sometimes the b will change before you get to the end of step 1. So that's another reason why it's so important to finish step 1 before you go to step 2. But the b here is the negative 4. So what you do, let me bring it up here, is according to the thing here where it says b over 2 squared, let me just go ahead and write that down. B over 2 squared is what we want to figure out, right? B over 2 squared. But the b is negative 4. And so it's negative 4 over 2 squared. So what you do is you figure out what the inside of the parentheses equal to first, because parentheses come before exponents in order of operations. And so we get negative 2 squared, which is, then we do the exponent and we get 4, don't we? Okay, so here's what you do. It says, again, to take that answer and to add it to the side that has the variables on it. I'm going to actually use a different color here just to highlight it since it's so important, such an important step. But as you guys know, you can't just add something to one side of an equation without adding it to the other. Okay, but there was a very good, and so make sure to do that as well. Add it to the right side also. But there's a very good reason why I figured out the 4 and then added the 4 to what I already had on the left. All right. It's because if I were to factor that, and there's actually a shortcut to the factoring, and I'll show you here eventually, but the factoring right now is not too bad. Doesn't this look like the Berry method right here? And yes, I know that there's not a 0 over here, okay, but remember, this is a different method, so we can factor this even though there's not a 0 over here, okay? Remember, you got to have a 0 over here if you're using the factoring method in order to be able to factor this, but this is a different method. So doing the Berry method here, factoring this thing, I get what? I get... I need 1 times 4 right here. 1 times 4 is 4. Okay. But I need the two numbers to add up to -4. All right. That I pick. And so -2 and -2 equal 4 when I multiply them, but they add up to -4. So that must be the correct two numbers to pick. Okay. By the way, the other side, go ahead and figure that out as well. That's -4. But here's the thing. And if this does not happen, you did something wrong. So please go back and figure out what went wrong. But these two brackets, you guys, should always be exactly the same. Always. And that's why they call it completing the square. Because when two brackets are exactly the same and you're multiplying them, doesn't that mean that you're squaring the bracket? Because squaring means you're multiplying the same thing twice, correct? And so if you're multiplying the same bracket twice, it means you're squaring the bracket. So please write it that way. All right. You'll see why here in a second, but please write it that way. But we took we took something that where you did not have a bracket being squared, and you converted it so that you now do have a bracket squared. That's why they call it completing the square. You're developing a bracket squared where the problem originally did not have it, and now it does. All right, now. Why would I do all this? It's because now the last step of the problem is to realize that this looks just like a problem on the front side of the worksheet that we just did for the square root property. All right. We learned on the front side of the worksheet that when you got a bracket squared all by itself on one side of the equal sign and you got a constant number on the other side, that means that you can do the double square root and cancel out the exponent too and all that stuff. All right. So we can finish off this problem and solve for x by doing that same exact set of steps. So let's do that. Write down x minus 2 twice, just like I did on the front side of the worksheet. And then we do the double square root. Square root of -4. And remember, this is one of those problems where you've got, where it says express your answers in terms of I. It says that on the front side here, okay, in this section. Sorry about that. In this section here, and that includes the entire 8.1, including the problems on the back, express your imaginary answers in terms of I. And so don't just say, hey, this is no solution because these radicals aren't real numbers. I know they're not real numbers, but again, they're imaginary numbers because you have the square root with a negative number underneath. What is that equal to, by the way? The square root of -4. Like I said, usually when you get the square root of a negative, you immediately get that, turn it into a positive and get that I out of there. All right, so I'm going to put that up here. Because there's one other step we can do with that as well. Isn't this I square root of 4? So get that I out of the right away. We usually do that. And then, what is the square root of 4? It's 2, right? So actually, that whole radical ends up being equal to 2I. Okay? And so what we end up with here is... And you could either simplify the radical now, meaning the 4, or you can simplify it at the end, but it doesn't hurt to simplify it now. So we get we get 2i and negative 2i. Okay. And then what we need to do is, obviously, just like we've been doing with the square root property, is we then need to move the 2 over in order to get the x by itself. All right. 2i is a constant number, even though it looks like a variable because of the i is not a variable. All right, because it's equal to the square root of negative 1. All right, it's actually equal to a constant number, remember. So again, this is a linear equation. All right, don't be fooled by the 2i. It's just like the square root of negative 4, where we said earlier, that's a constant number, just like, just like if you had a 10 right there or a 12 right there. All right, and 2i is the same way because it's the same thing as the radical. All right, it's just like having a 10 there or a 12 there. You would add the 2 over to get the x by itself. And if I did that, what do I get on each one of these here? I get, now remember, before you actually write it here, remember, these are not like terms. So don't combine them. Just say that they're being added together or subtracted, all right, depending on how it's written. So we get what? We get 2i plus 2 is 2i plus 2. And negative 2i plus 2 is just negative 2i plus 2. You cannot combine those. But what we should do, though, is, let me write it down like this right here. Like we talked about in section 7.7, it's not the end of the world if you don't do it here, unless they ask you to write it in a certain way. You can say 2i plus 2 and negative 2i plus 2. That's okay. But usually when we have a regular term that does not have I in it, and then a term that does have I in it, we usually put the regular term without the I first. Again, we did that in section in section 7.7. So it would look like this, wouldn't it? It would look like these two answers right here. Okay, so you could go ahead and circle those two answers right here. All right, but how can we condense that answer down? Remember, the two answers are exactly the same, except for you got a plus or a minus in the middle. Everything else is the same. So condensing down that answer, if you prefer, all right, and it's good to get used to that. Like I said, it's 2 plus or minus 2i. And so that is the final answer right there. Okay, so remember to express your answers in terms of I if it's the square root of a negative number. Okay? Moving on here to the next part. Next problem. Okay, it gets a little bit more tedious now, all right, but we'll be all right. We just got to be patient. Okay, what we need to do this time, again, is we need to move over the... Remember, we're supposed to have the x squared and x on the same side, but we can't have the constant term over here with it. It's got to be on the other side. And assuming there's no parentheses or anything, we move that over by adding or subtracting it over. However, what's that big other thing that we need to do that we already talked about that you need to do before you get into the second step up here with this b over 2 thing? You have to get rid of the 3. Okay, you cannot have 3x squared there. You've got to have x squared before you do this b over 2 thing. And it's so important because what's going to happen when I change the 3x squared to an x squared? What's going to happen is that the negative 6 is no longer going to be negative 6. And so if you take the negative 6 right now and try to plug it into this formula, it'll be completely wrong because it's not going to be negative 6 anymore by the time I'm done converting this thing to x squared. All right? That's, again, why it's so important to do the steps in the right order. How do we make this into x squared? The way you got to do it is you divide out. You divide out by the coefficient. All right? So if that had been 5x squared, you divide by 5, for example. But since it's 3x squared, we're going to divide by 3. But you can't just divide one part of an equation by something without dividing the entire left side. That's why I use the big bar here. And then the entire right side, too. Okay, how do we divide two terms in a numerator divided by one term down here? We divide each one individually. We've done that a number of times this semester. All right, I'll just write it up here. You don't have to show this work here, but just to review with you, it would look like this, wouldn't it? Right there. Okay, so What does each one of these fractions reduce down to, though? They reduce down to x squared, like we wanted. 1 x squared over 1 is the same thing as just x squared. And then this is 2x over 1, isn't it? And so that would be the same thing as minus 2x, because you don't need to write the 1 underneath it. Still got this fraction over here on the other side. That's fine. We'll deal with that. But we did it, you guys. We got 1x squared, not 3x squared, but 1x squared. The 1 is invisible, but it's 1x squared. And then the x term, okay, and then you got a constant term over here with no variable in it. That means we are now ready, and not before that, but now we are ready to take the coefficient, which notice it's no longer -6, it's -2, all right? We take that and we plug it into this formula over here. Okay, so that would now make that what? That would make that -2 over 2 bracket squared. What's that equal to? Parentheses first, -1. We square the -1 and we get 1. What do we do with that 1? We do the same thing as we did in the last problem with the 4. All right, we add that number to both sides of the equation. I'm using my red pen again. You don't have to use any color, but I just like to do that, as you know. Okay. Then what do? We then factor, after you add that same thing to both sides, you factor the side with the variables on it. Yes, that's the Berry method. And if you do the Berry method on that, yes, it will end up being the same two brackets. If it's not, you did something wrong. But it is. It's x minus 1, x minus 1. What is the -2/3 plus 1? That is the same thing as -2/3 plus 3/3 if we get a common denominator, which you need because you're adding. Adding fractions means common denominator. So wouldn't that be 1/3 right there? -2 plus 3 gives me 1 with the 3 there. Okay, and then what do we have here? Just like in the last problem, once you get the two brackets to the same, we rewrite it as bracket squared. Like that. Okay, and then bracket squared, you guys, what does that mean? Bracket squared. Excuse me. As long as you have a bracket squared by itself and a constant on the other side, which you always should if you do this, do these steps correctly. Once you get down to this point, you should have that. You then do the double square root. X minus 1, no exponent anymore, equal to positive square root of 1/3, and then x minus 1, no exponent again, equal to negative square root of 1/3, like that. And then what do I do in order to get the x by itself? All right, after I get rid of that exponent there, I need to add the 1 over to the other side, don't I? Okay. If I add the 1 over to the other side, I'm going to get 1. I'm going to get the radical plus 1, and I'm going to get negative radical plus 1. Okay, think about what that means, all right? Radical plus 1. I'll go and write it down. All right. The radical, I know we need to reverse it around, but I just want to make a point here. All right. You could put the radical first. It's just that usually we don't. Okay, we usually put the, when you have a regular term being added or subtracted with a radical term, we usually put the regular term in front. Okay. So we can reverse that, and now I'm going to go ahead and reverse it around. You could have done that right away. I just didn't want to go too fast. Okay. So what does that become here? That becomes x what? It's going to be 1 minus the radical, reversing these around, positive 1 minus the radical, and positive 1 plus the radical. Well, what does that mean if I condense that down to one statement? Wouldn't that be positive 1 plus or minus the radical? Like that? All right. And again, The textbook likes to rationalize the denominator when they have a fraction inside of a radical in their final answer. But again, that is completely optional. You don't have to do that. Okay, you can leave it like that. All right, now one more here. Okay, and then I'll let you guys try a couple. Next one. Again, we need to move over the 4 because you can only have the x terms on the left side, and you have to have, well, doesn't matter what side it's on. The point is you got to have the x terms on one side, whatever side that is, and then you got to have the constant terms on the other. So I did that. Write that down. But then after you get the x terms on one side and the constant terms on the other, you then have to get rid of that 2 right there. It's going to be a little bit tougher this time to deal with that, and we're going to end up with a fraction here right away. But just like in the last problem, you have to divide by the coefficient of x squared. Okay? And what happens here? Positive divided by positive is positive. Okay, and we get what again? We get 2x squared over 2. There it is right there. And then we get positive divided by positive is positive again. So we get 3x over 2. The other side is equal to 2 here, as you know. But the 2's cancel right here. Again, put each fraction in the lowest terms here. We get x squared. And then, just like we did on the mx plus b problems, you guys, when we graph lines, all right, take the x right here, and since it's being multiplied by the 3, please put it behind the fraction there. All right, so you can clearly see what is being multiplied by the x, just like we did when we were trying to figure out the slope. Put it behind that. All right. I wouldn't want you to think that the b number was equal to 3 here because it's being multiplied by x. Normally that would be true, but if there's a fraction with the x in the top, you need to pull the x out so you can see the entire thing that is being multiplied by x here. It's not just 3, it's that entire fraction. Okay, so let me go ahead and move this entire equation back down here. It's going to be x squared, as you can already see there. X squared plus 3 halves x is equal to 2, like that. All right, now, what do we do with that? What we need to do, and this is where, again, it gets a little bit more complicated, okay? Our b number is a fraction this time, so we got to be a little bit more careful, in other words. All right, here's what you do. The b over 2 formula, what you do is you put the 3 halves up there. The 2 is still down here, so there's going to be a couple of 2's inside the bracket here. Okay, let me show you how it looks. We have 3 over 2 divided by 2. Again, the b number is 3 over 2, so that's separate from the 2 that's underneath. That's why we got, like I said, a couple of different 2's inside the bracket. But so how do I do this? Okay, remember, you got to figure out what the bracket, the parentheses, equal to before you square it. How do I do a fraction divided by a whole number? What I do is I take the whole number and I make that into a fraction also, 2 over 1. And since we're dividing fractions, as you guys have done many times before, dividing fractions means to multiply by the reciprocal of the second fraction, 3 over 2 times 1 over 2. And wouldn't that be equal to 3/4 right there? 3/4. We still need to square it. I just figured out what the inside was equal to. I haven't squared it yet. Okay, so now what is 3/4 squared? Well, when you square a fraction, it means to square the top and the bottom. And so that would be just simply 9/16. 9/16. So a lot of work on that one just to get that number. But that's what happens when you got fractions inside your equations. Sometimes there's a lot more work to do. So I need to add what? I need to add 9/16 to both sides of the equation, like that. Okay. and then I need to factor the side that has the variables on it. And I know you're immediately thinking, whoa, 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 how in the world do I factor that with all those fractions in there? Well, that's where the shortcut comes in that I promised a couple of problems back. In the first two problems, I was able to factor it no problem because there was no fractions and it just looked like a normal Berry method situation that we've done a number of times before. But when you got fractions, that's a whole different thing. So there's a shortcut though, thankfully. All right, after you add the appropriate number to each side that you get from the b over 2 squared formula up here, all right, there is a shortcut. You can go right to this step right here where you have the bracket squared. Okay, you can go straight to that. And before I show you what it is, before I tell you what it is, let me show you by showing you that it works over here, the shortcut. Notice that the thing that I squared here, not the actual answer, which was plus 4, but what did I square to get that number? I squared -2, right? So I'm not talking about the final answer there on that, but just the number you squared to get that number that you add to both sides. That number was -2. And sure enough, it's not a coincidence that -2 goes into the bracket along with the variable. Let's try that again. Look at the next problem. What was the number that I squared to get the number that I added to both sides right here? That number was -1. And sure enough, what goes inside the bracket with the variable? -1. If it had been +1, then you would have said +1. Okay, but because it's -1, you say -1. So here's the thing. What did I square to get the 9/16 that I added to both sides? I squared not 3/2, but 3/4. It's whatever you get after you divide by 2 before you square it. Okay, that's the number that you're looking at. Since that's positive 3/4, we are going to say x plus 3/4. Say plus when it's positive. But that's the shortcut. Just look at what you are squaring here. And please remember, a lot of people miss this. Please remember, this is x now. It's not x squared. Okay? Remember, when it goes down into the bracket right here, it's always just the variable. It's not variable to the second power. It's just the variable. Okay? So same thing here. That's just x, not x squared. All right? So that was a nice little shortcut. We actually skipped 2 steps right there. You didn't have to do the 2 brackets here. You just jump right down to it, and that's what we did. But we do need to add the 2 and the 9/16. Again, we need a common denominator. 2 over 1. 2 over 1, if we multiply both of those numbers by 16 right there, I get, it's a multiplication right there, 32 over 16. So if I add that to 9/16, what do I get? Okay. I get 41/16. 32 plus 9 is 41. Okay. Kind of a weird looking thing here with those fractions, but it's still the same idea, you guys. Bracket squared. By itself, nothing else but the bracket and the square on one side of the equation. Constant number, no variable on the other side. That means it is now time, and not before that, but now it's time to get rid of the exponent, write down the inside of the bracket 2 times, just like normal. Okay, when we do the square root property, just like normal. And then the number that's on the other side, you take that and you do a double square root with that. Like this. Okay. All right. And then, again, don't be tripped up by those fractions. They're constant numbers. All right. It's no different than if you had x plus 2 right here or x minus 3 right here. You just move that constant fraction over to get x by itself by either adding it or subtracting it over. Okay. Just like before. So we're going to subtract the 3/4 since the 3/4 was positive. Subtraction is the thing that you do. The 3/4 cancel on the left. And we get what? We get x is equal to, and again, I'm going to put the regular number that's not a radical. In this case, the regular fraction that's not a radical. I'm going to put that first. It's negative, so put the minus in front of it. The radical is positive on the first one here, so I'm going to put a plus in front of that one. Okay. And then the other one, same idea, negative 3/4. Okay. Minus the radical. Remember, you can put since the fraction is negative right here, negative divided by positive. Actually, it was already outside anyway. I just got a little bit lazy there, excuse me, by making it look like it was inside. So never mind. It was already done. I was going to try to move the negative sign outside. It was already outside. Anyway. So there you go. All right. Yes, I could rationalize the denominator. Okay. Don't need to, though. I get negative 3/4 plus or minus the square root. Okay. That's a perfectly acceptable answer, but what a lot of what the textbook likes to do, let me just show it to you once or twice here, since a lot of you like to compare your answers, and I always recommend that you do that anyway to make sure you're getting your homework problems right. This is what? This is square root of 41 over square root of 16. You got to split it before you can split it into two separate radicals before you rationalize the denominator. But this one's nice to us. See how the denominator has a perfect square underneath it? Okay, normally it doesn't, but because it does, you don't need to multiply by something like you normally do when you rationalize the denominator. Just evaluate it since it's already a perfect square. But I want you to notice something here. We have negative 3/4 plus or minus square root of 41 over 4. See how the denominators are the same? Since they are the same, again, optional thing that I'm doing here. This is just what the book does. All right. I need to move the negative, though, into the 3 here. Because anytime you add or subtract fractions and you have a negative in the front of the first one, you've got to move it into the numerator. Otherwise, it'll look like the negative applies to the whole answer. It's only supposed to apply to the first part here. So negative 3/4, and then since it's got a common denominator, I can add the numerators together. Negative 3 plus radical 41, negative 3 minus rad 41. You can do both at the same time with the plus minus symbol like this. And let me reposition my 4 here. I made the 4 look like it's way over on the left here. It's okay to put it there, but it's just easier to put it in the middle. So that's how the book writes the answer. You don't have to do that, like I said, but just to let you know, that's how the book is doing it in case you see the answer in the back of the book and you're wondering, hey, why does my answer look like this when the book looks like this? Well, it's the same. All right. So that's one thing that you could do, but that's because the textbook does it. It's optional overall, though. It's optional. All right, so please try right now problems 4 and 5, keeping in mind that shortcut that I taught you about how you can skip over the factoring step and just put the right number in there. Okay, you're going to need that actually for the number 4, not number 5, but you will for number 4. So please try those 2 problems right there, and then, of course, as usual, hit the play button when you're done. Okay, let's take a look at number 4 here. You can see that, once again, we need to have the constant terms on the opposite side of where the x terms are. So I added the 5 over. And I get x squared. I know I've got all this other stuff in here, but x squared minus 3x equal to 5. The 9/4 came in there after that. I'll show you how I got that. But x squared minus 3x equal to 5 was originally in there. Notice that that's x squared, not any number in front of x squared. It's just x squared. Then the x term, and then a constant term on the other side. That's exactly what we want. So then we take the b number, which is negative 3. We plug it into the b over 2 squared formula right here. and you can't do anything. Normally at this point you would try to put this thing in lowest terms, or if there's a fraction on top like we saw in the last problem, you would try to divide the fractions. All right, but there's nothing we can do with this because you just got two numbers, just two single numbers here, no fraction or anything on the top like we saw, but just two normal numbers that cannot be reduced. This is already in lowest terms, and so all we can do is just square both the top and the bottom. Remember, when you square a negative, because you've got to square the entire numerator, that includes the negative, and when you square a negative, it's going to be positive, isn't it? So be careful there. All right. So this should be positive 9 over positive 4. All right. And so that gives me 9/4. So that's why I added the 9/4 of both sides. Okay, now, how did I get this, though? Well, that's where the shortcut comes in. Again, we have a fraction here in this thing that we normally have to factor, all right? And we don't usually factor when we got fractions, okay? Completely understandable if originally you were thrown off by that. But like I said, no need to factor when we have this shortcut. What was the thing that we squared to get the thing that we added to both sides, 9/4? It was -3/2. Notice that's a negative fraction, okay? Because it's negative divided by positive. Since it's negative, all right, we need to put the minus there, all right? In other words, what you realize, you guys, that you need to realize that when you have a negative constant number divided by a positive constant number, just a single term on the top and bottom, as we've seen before, you can move the negative to the front of the fraction. And that's why, but it doesn't stay in the 3 at the same time, all right? You move it to the front, but it's not with the 3 anymore. Okay, so just put the minus there in front of it, all right, because it's negative, and then you just got a positive 3 right there, okay? Just want to make sure you don't end up with two negatives there, all right? And the other side ends up being equal to 29/4, and the reason why I know that is because 5 is the same thing as 5/1. 5/1, let me put that right here, 5/1 is the same thing as 20/4 if you multiply the top and bottom by 4. 20/4 plus 9/4, that's equal to 29/4, and that's why I put that right there. Okay, now I've got a bracket squared all by itself, constant number on the other side. What do? I get rid of the exponent, write down the inside of the bracket twice. I do the double square root, and then I need to get the x by itself after that. How do I get the x by itself? I add the 3/2 over to the other side. Final answer, unless you rationalize the denominator, would be 3/2 plus or minus the square root of 29/4. And if you do rationalize the denominator, you then what? You then split it. And hey, the denominator rationalizes itself. You don't need to multiply by anything because it's a perfect square, 4. It becomes 2. And then since these two fractions now are both have the same denominator 2, 3/2 and radical over 2, I can then add them together into one fraction. Okay. 3 plus or minus square root of 29/2. Again, completely optional on this last step here. If you circle the first one and stop right there, you'll get full credit, no problem. Okay. Last one here, number 5. Again, you got to move over the constant terms to the same side. So I added over the 14. I then need to get rid of that 2, don't I? Cannot have 2 there. I've got to have y squared, not 2y squared. All right. And so I need to divide by the coefficient 2. That means I need to divide all 3 of these terms by 2 here. I did that here, and I got 2y squared over 2. The 2's cancel. If you split that, you can't cancel the way it's written right now, but if you write these two things as two separate fractions, like we've done with mx plus b problems and similar things, then the 2's would then cancel. I could write it down over here. This is basically how how it would come out. 2y squared over 2 plus 8y over 2. Now that you have a single term on the top and bottom of each fraction, now you can reduce it in the normal way. The 2's cancel. It gives you the y squared. The 8 and the 2 reduce down to 4 over 1. You can just write 4. And then the y gets put behind that, like I mentioned in a previous problem. All right, put the variable behind the fraction so that you can see that that is, well, actually, you don't need to do that here, because if you reduce this, it's not even a fraction anymore. It's just that when it is still a fraction and you can't reduce it anymore, then you want to put the variable behind that so you could see that the entire fraction is being multiplied by the variable. But there is no fraction here anymore, so never mind I said that. Excuse me. So we now have this thing right here that is in the form that's supposed to be in. The variable squared with nothing in front of it, then the variable to the first power, y to the first, and then no variable at all on the other side. So that means I'm now ready to take the 4 and plug it into the b over 2 squared formula. All right, if I do that, I get 2 squared, which is 4. So that means I add 4 to both sides. Okay, I add 4 to both sides, just like I've been doing. But how do I factor this over here? Since that doesn't have any fractions in it, we can reasonably factor that in the normal way with the Berry method. But why not use the shortcut now that we've learned it? The shortcut says that since the thing that I squared over here was 2, positive 2, I'm going to say y plus 2 inside of my bracket. And so that saves us some time, right? Okay, as long as you know your shortcut, okay, you can go and use that. Finally, we now need to do the square root property in order to finish the problem off. How does that look? I get rid of the exponent, and then it becomes a double square root simultaneously. And then I need to move the 2 over to the other side to get the variable by itself. So I subtract the 2 over, and we end up getting negative 2 plus square root of 11, negative 2 minus square root of 11 if you put the negative 2 first. And so negative 2 plus square root of 11, negative 2 minus square root of 11, that's why you have the plus or minus right there. It's because both answers have negative 2 in the front, both answers have the square root of 11 in the back, but the difference is that one of them is plus in the middle and one of them is minus in the same place. And so that's when you can use the plus or minus symbol. All right. So that's completing the square. In the next section, we'll look at the fourth and final method that we have available to us for solving quadratic equations. All right. And but in the meantime, let me know if you have any questions about any of this stuff from section 8.1. Take care.